Unit 6, Lesson 5, finding the lengths using the primary trig ratios. So I'm going to show you today how to find lengths using primary trig ratios. Before we get into that, I'm just going to review how to find these angles. So how do you find angles x and angles y? So I'm going to start with x. X is going to be my reference angle. And because I have all three sides of this triangle, I can use any of the three ratios because I can plug in either the opposite side, the hypotenuse, or the adjacent. So I'm going to pick the sine ratio. So the sine of my angle x is equal to the opposite side divided by the hypotenuse. And so if I plug in the values that I know, opposite is 60, and the 60 is again opposite of the angle. 25 is my adjacent side because it's touching the angle. And here my hypotenuse, the longest side, 65. So the ratio is 60 over 65. Now remember, this is just the ratio. So 60 divided by 65 equals 0.923. So 0.923. Let me go one more. So around 9231. So approximately equal to 0.9231. However, if I want angle x, you still have to take the inverse of that ratio. Okay, so if I took the inverse of this answer, I would get 67.38 degrees. So I'll just round that to 67 degrees. Okay, now if I want angle y, remember the rule that sum of all three angles inside a triangle add up to 180. So y would have to be 180 minus the 67 degrees we found minus the 90 degrees in the right angle triangle, leaving us with 23 degrees. So y is 23 degrees. Okay. How can we use the angle to determine the slope of a triangle? Now remember something here. Here's a triangle. 18 degrees is my reference angle. In reference to 18 degrees, I have opposite over the adjacent. And that adjacent side is touching the angle. Opposite is opposite of the angle. Hypotenuse will still be the longest side. But now have a look at this. The tangent ratio. We haven't looked at the tangent very much. Tangent ratio is defined as the length of the opposite over the length of the adjacent side. Opposite over the adjacent. Again, I'll highlight opposite over the adjacent. Now imagine for a moment you had a point here at this end of the triangle and a point up here at this end of the triangle, and what you make between 2 points is a line. Okay, what would the slope of that line be? Well, you'd measure the rise of between those 2 points and the run between those 2 points. Rise over run, and you're kind of creating a triangle. Think back to all those grade 9 lines that you drew on graphs, how you're making triangles between one point and the next and finding rise over run. So the way you calculate rise over run is it parallels trigonometry, the way you calculate opposite over adjacent. So you can use the tangent ratio of an angle in that triangle to help you find the slope. So a tangent of 18 degrees, so if I put 18 degrees, the tangent of 18 degrees is 0.3249, 0.3249. So that says the ratio of my opposite over adjacent in this triangle is 0.3249, but that is also the same as the slope. The slope of this hypotenuse line is 0.3249. So that's a little interesting connection between linear relations and trigonometry. Example 2, determine the values of sine, cosine, and tangent ratios for angle A and for angle B to 4 decimal places. So just reminding ourselves how to write down ratios. I'll calculate sine of angle A, cosine of angle A, and tangent of angle A. And I'll use these degrees in the triangle. So sine of angle A is sine of 67. We do sine of 67 on my calculator. 0.9205. Make sure you are in degrees. If I do the cosine of angle A, so the cosine of 67 degrees, I'll get another ratio here. So 67 cosine, 0.3907. And if I do the tangent of 67 degrees, same idea. So 67 tangent, 2.355. Okay, now I challenge you guys, pause the video, you do the B. Calculate sine of B, cosine of b, and tangent of b. What are they? Okay, so hopefully you had an opportunity to do that. So sine of angle B is 0.3907. Cosine of 23 degrees is 0.9205. And the tangent of 23 degrees is 0.4244. Okay. Now, let's really get into how we are going to be solving through the side length. So here's the real examples for this lesson. Solve the following triangles. Let's determine all the angles and all the side lengths. So another new thing here for everyone, when you say solve, it's not like solving an equation where you find one unknown value or two in a quadratic possibly. When you're given a question like solve the triangle, it means find all the unknown angles and the unknown side lengths. So when I look at part A, I'm going to be looking for x. I'm going to be looking for this side up here. Let's call that y. And I need that angle in there. Well, this angle in here is pretty simple. It's 100. It's a, take 180, but take away 90 is 90, and 90 take away 60. What's left over is 30. So it's 90 minus 60, which is 30 degrees. Because all three angles inside a triangle have to add up to 180. Okay, now, next. What am I looking for? I'm looking for x. If 60 degrees is my reference angle, x is going to be my adjacent side, and 4.3 kilometers is going to be my hypotenuse. So you think, okay, which trig ratio links the adjacent and hypotenuse? And that would be the cosine ratio. The cosine of my angle 60 degrees is equal to the adjacent side x divided by the hypotenuse side 4.3. And so now what you have here, now we're not solving for an angle because we have the angle now. What we don't know is a side length. So because this unknown side length is part of the cosine ratio, I can use it to help me find it. So as long as that's the only unknown variable, this x, I can now treat this as if it was an equation and solve for x. So if I'm solving this, I'm going to multiply both sides by 4.3. So what I get is cancel, cancel. X equals 4.3 times cosine of 60. That's always important to write the number in front of the trig ratio. And the reason why that's important is because sometimes students might write this, cosine 60 times 4.3. If you do it incorrectly on the calculator, or people read it incorrectly, they'll think you're multiplying the angle by 60 before doing the cosine, when that's not the case. You're actually doing the cosine of 60, and then whatever that result is over here becomes multiplied by 4.3. So let's do that. 60, the cosine of 60 is 0.5. Multiply that by 4.3, and you get your answer, x equals 2.15. Okay. Similarly for y is the opposite side. So if I want to solve for y, I could say I can use the sine ratio because opposite over hypotenuse is the sine ratio. Sine of 60 equals the opposite y divided by the hypotenuse 4.3. Okay. You could also use a tangent ratio, opposite over the adjacent, but I will avoid that for now because if you made a mistake with the x, then you'll definitely make a mistake for the y. So use the ratios that give you the most known values, given values. Okay, so solving for y, I multiply both sides of my equation by 4.3. So 4.3 times sine 60 equals y. And so when I calculate that, sine of 60 times 4.3 equals 3.7239. So y equals approximately 3.723. Okay, and these are in kilometers. All right. Looking at the next triangle, similarly, you're asked to find an unknown side length. So if my reference angle is 39, this x is my adjacent side because it's touching the angle, and 30 is my opposite side. So the ratio that relates the opposite and the adjacent this time will be the tangent ratio. So tangent of 39 degrees equals the opposite length 30 divided by the adjacent length x. Now, solving for x takes an extra step because x is on the bottom. So here is how you can treat this. What if I write this as tan over 39, and actually let's not do it that way. You can cross multiply. If you're familiar with cross multiplication, you can. But imagine for a moment you want to bring the x to the top, right? The numerator. So if I multiply this side by x and multiply this side by x to balance everything out, what would happen is that this x in the denominator will this cancel with this x in the numerator, and you're left with x times tangent of 39 equals 30, and then I'll divide both sides by tangent of 39. So if I divide both sides by tangent of 39, these two cancel, and I'm left with x equals 30 over tangent of 39 degrees. Okay, now can I go from here to here in one step? Yeah, you can. So if you see tan 39, if you see a ratio and the unknown variables in the bottom, all you got to do is take that denominator and switch them around so that you get x on the left side and 30 over tan 39 on the bottom. So you're just making them switch places, which is exactly what you end up having here. So, but make sure when you're doing that, you understand what really is happening is all of this. Now I can just calculate x. So it's going to be 30 divided by the tangent of 39 degrees, which is equal to 37.04. So x equals 37.04. Maybe I can just round that to 37. Okay, so x here is 37. That's centimeters. Okay, let's see what else we have to solve in this triangle. I have to know the other angle. So this angle down here, well, that's 90 minus 39 because some of all three angles have to add up to 180. So 90 minus 39 is 51 degrees. Okay, and then the hypotenuse, the third side. Well, for this one, you could use another trig ratio. You could use Pythagorean theorem, not that you have the other two sides. Let's use a trig ratio. So I will relate the opposite and this hypotenuse with 39 degrees being my reference angle. So the sine of 39 degrees, if I use the sine ratio, the reference angle is there. Opposite is 30. Hypotenuse is my unknown. Let's give the hypotenuse a letter. Let's call it y. So sine 39 equals 30 divided by y. And again, the unknown variables on the bottom. So the way you can quickly solve this is to switch the y with the sine 39 on the left side at the top, so that y equals 30 divided by sine of 39 degrees. And that's going to be, so 30 divided by the sine of 39 equals 47.67. So y equals 47.67 centimeters. I can round that to 48. Okay, so that's how you use the trig ratios to find unknown sides. Let's do an application problem. So Janice is getting ready to climb a steep cliff. She needs to fasten herself to a rope that is anchored at the top of the cliff. To estimate how much rope she needs, she stands 50 meters from the base of the cliff and estimates that the angle of elevation to the top is 70 degrees. How high is the cliff? So here's my cliff. Rope is fastened to the top of the cliff. Janice stands 50 meters from the base. And here's her rope. And she's estimating an angle of elevation of 70 degrees. So first of all, there's a triangle here. Okay. And cliff makes an angle of 90 degrees with the bottom. So there's my 90 degree angle. Angle of elevation is 70 degrees. So what is angle of elevation? Angle of elevation means if you measure from the horizontal, what's your angle going up? So we're looking at this angle right here. That's angle of elevation. In some questions, you might get angle of declination or depression, which means you're starting from the horizontal and you're measuring the angle going down. Okay, so that's going to be a new word you might see here in math. Angle of elevation. It just means what is the angle that you're measuring when you're looking up. It's from the flat horizontal ground looking up. Okay, and the only dimensions we're given is the 50 meters from the base of the cliff. So how high is the cliff? Let's put h over there for the height. We're not asked for the hypotenuse, just the vertical height. Just to not get confused, maybe we'll use x instead. So h can sometimes be confusing. So let's use x for my height. So how high is the cliff? Find x. So here we go. What ratio am I going to use? It's a trigonometry problem, right angle triangle. I have an angle. I have one side and an unknown side. We're going to use a trig ratio. So 50, if I label my triangle first, the 50 is my adjacent side because it's touching my reference angle. The angle of elevation will be my reference angle. And x is the opposite side. So the ratio that relates opposite and the adjacent will be the tangent ratio. The tangent of your angle, 70 degrees, is equal to the length of the opposite side over the length of the adjacent side. And when I plug in the numbers, the tangent of 70 degrees equals x over 50. And so to solve for x, treat it like an equation, multiply both sides by 50, so that the 50s cancel on the right, and on the left you have 50 times tangent of 70. So 50 times the tangent of 70 degrees equals 137.37. So x equals 137. Well, let me write it out completely. So x equals 50 times tangent of 70 degrees, and when you calculate that out, it's 137.37. So 137.37 meters. And that's the answer. You can say here, therefore, the height of the cliff is 137.37 meters. And so that is how you use trigonometry to find unknown side lengths. Practice problems for you to do, and that ends this video.